So yesterday's maths came out something like this. I can't remember the full question, but I do somewhat remember the important points. Okay, so anyways, so we have a regular pentagon, and we are informed that these 5 sectors are congruent sectors, means they have the same size. Okay, so the first thing we're going to do is that given the perimeter of the yellow region, which is this part, is 18 pi cm. Okay, then find the side length of your pentagon. Okay, so the first thing I'm going to do is to find what is the size of this angle, right? Okay, so since it's a regular pentagon, so we can just use the formula, which is 5 minus 2 times 180 divided by 5 sides, right? So 3 times 180 divided by 5, you get 108. Okay, so I like to change it to radian form, so just use 108 times pi over 180. Okay, so you would get 3 over 5. So it's 3 over 5 pi. Okay, so you know that this angle is 3 over 5 pi. Okay, then you should use S equals to r theta. Okay, so your r is an unknown, right? This is your r and this is your theta. Okay, so r times theta is equals to the perimeter here, right? And 18 pi is the perimeter for 5 sectors. So you just have to times 5 and it will be equals to 18 pi. Okay, so pi and pi you just cut, and r is equals to, okay, 18 divided by 3 ma, so it's 6. Okay, so your r is 6 now, and these sectors are all similar, right? So this is 6 and then this is also 6. So the side length of your pentagon will be 6 times 2. So it's 12. Okay, so we're done for part A. Then for part B, they said that a red circle with maximum radius is drawn on the yellow region. So find the area of the remaining yellow region. Okay, so what they mean by maximum radius is the circle should be as big as, you should draw the circle as big as you can, right? So it should be touching the tip of the blue sectors. So it somewhat looks like this. Okay, I'll draw it out for you. I'll draw the intersecting points first, so that it will be a nicer circle. Okay. Okay, somewhat. Yeah, can okay. So what they mean by area of the remaining yellow region is these parts that are not covered by the circle, right? These 5 parts. Okay, so the strategy here is to find the area of your pentagon minus with the area of 5 sectors and the area of your circle, right? So okay, so the question is, how do you find the area of your pentagon? So I would suggest that instead of thinking of it as a pentagon, you think of it as 5 triangles. Okay, so how you're gonna do that is, okay, I'll draw it out for you so that it's more obvious. Okay. Okay, can you see it now? Okay, this is the first triangle, second one, third one, then the fourth one, and the fifth one. So there's 5 triangles here. Okay, so let's start on working on finding the area of one triangle. Okay, so this is your triangle, right? And these 2 sides are the same length. Okay, then you divide this sector by 2. So this size is 3 over 5 pi, right? When you divide by 2, it becomes 3 over 10 pi. So this angle will be 3 over 10 pi. Then because it's isosceles, so this part will also be 3 over 10 pi. Okay, so what is the size of this angle? This angle will be 180, which is pi, minus 3 over 10 pi times 2. So it's technically just pi minus 3 over 5. So it's 2 over 5 pi. 2 over. So this size here is 2 over 5 pi. Okay, then then you would need to find the this length, right? Because if you were to find the area of the triangle, you need to apply half AB sine C. Okay, so what I'm going to do is to redraw this triangle. Okay, so this triangle here, this is a right angle, and then this part is 3 over 5 pi, and okay, so this length is 6, right? Because you already find the radius. The radius of this sector is 6. And then the radius of the circle, you still don't know yet. Okay, so what you're going to do is to put this part as 6 plus radius. Okay, and this part you also know, right? This part is also 6 because it's also it's also the radius. So this is also 6. Okay, so now you just have to apply cos, sine, or tangent. Okay, so this one we have adjacent and hypotenuse, right? So it should be cos, wait. This is 3 over 10 lah. This one is 3 over 10 pi. Yeah, because it's in radian, right? Okay, so then adjacent over hypotenuse. Okay, then you find your radius of your circle. Okay, so you're going to have to change it to radian mode, and then cos 2 over 3 times 3.142. Oh my god, 2 over 10, sorry. 142. Okay, ayo, what was I doing? Okay, then 6 divide by answer, minus with 6 again. So your radius would be 4.2095. Okay, so this is your radius, right? And then the hypotenuse, which is the side of your triangle, would be radius plus 6, right? So it's 10.2095 is the length of this. Yeah, it's the length of this part. Okay. So next you can start calculating the area. Okay, area. First you should find the area of one triangle. One triangle should be half AB sine C, right? Half AB. What is your A? Your A is this length, which is 10.2095. And then B is also the same length, right? 10.2095. sine c. C is 2 over 5 pi r. And then you times 5, because you have 5 triangles, right? So times 5. Okay, then minus with, okay, the area of sectors. Okay, so area of sectors is half r squared theta. Half r squared, what is your, this length is 6, right? So it's half 6 squared theta. Theta is 3 over 5 pi. Then you times with 5. Okay, then you minus with the area of the circle inside. Circle is pi r squared lah. Okay, pi r squared. The radius of the circle we already found, which is 4.2095 squared. Okay, then just key in calculator. So it's 5 over 2 times, yeah, okay, 10.2095 squared times sine 2 over 5 times 3.142 minus with, okay, 5 over 2 times 36 times 3 over 5 and 3.142 minus again with 3.142 times 4.2095 square. Okay, so you would get 22.50. Yep, and that's the final answer, okay, of these remaining yellow areas. Okay, yep, I can't guarantee that this is the correct answer, but at least that's what I wrote lah for yesterday's in my booklet yesterday. Yeah. And yes, I do realize that this video is kind of pointless because no one is using KBSM anymore and our exam is just over. Yeah, but you know, talk about doing pointless things, right? I even colored the diagram twice. Yeah, just like how you clicked into this video, even though the exam is over. Anyways, thanks for watching.